Welcome to part 2 of the test review. We're picking up where we left off on number 11. So here it says evaluate the difference. So we're subtracting, write the result in the form a plus bi. And again, very similar to the polynomials or the algebraic expressions we did. Since we're subtracting, we have this minus sign we need to distribute. So if we do that, we get negative 9 plus I. That stays the same, and we distribute our minus sign, so we get minus 8 and plus 7i. Then we combine like terms, so the real part, the part without I, we have minus 9, or negative 9 minus 8. That gives us negative 17. Then if we look at the complex parts, the parts with i's, we have 1i plus 7i. So we get plus 8i. And this is in a plus bi form. A is negative 17, b is 8. And so we are finished on this one. Okay, number 12 says evaluate the product. So we just treat I like a variable for the most part until we get toward the end, and we may have to simplify. So we're going to do FOIL method here. Or really the distributive property, if you want to think about that. So 7 times 1, the first terms, we get 7. If we do the outer terms, 7 times I, we get 7i. If we do the inner terms, negative 3i times 1, we get negative 3i. And then the last terms, negative 3i times I, we get negative 3i times I gives us I squared. Okay. Remember a very important relationship. I squared equals negative 1, so we can simplify. Okay. So this thing is going to be negative 1, so we have negative 3 times negative 1. So there, negative 3 times negative 1 will give us positive 3. 7 plus 3 will give us 10 for our real part. Then for the complex part, we have 7i minus 3i. That will be plus 4i. So our A is 10, our B is 4. Okay, very important you remember this, that I squared is negative 1. Okay. Got to use that to simplify. Okay, anytime you get I squared, you can't leave that in your answer. Okay, 13, oh boy. Get to evaluate the quotient. This one looks fun. It's not that bad. Okay, it's not that bad. So remember, if we are dividing with complex numbers, really what we're doing is rationalizing. So we got to multiply by something over itself. And the thing we multiply by is called the complex conjugate. To get that, all we do is we change this sign. Just take the opposite of whatever that sign is. So here we're going to multiply by 4 minus 5i over 4 minus 5i. Okay. Let's see what we get. So we got FOIL method to do on top, FOIL method to do on the bottom. Okay, on the bottom you can use the shortcut. There's a pattern. If you prefer to do that, that's okay. FOIL method works. So here 6 times 4 is 24. 6 times negative 5i is negative 30i. Okay, outer terms 6 times, inner terms negative I times 4, negative 4i. And then negative I times negative 5i, well, that turns into plus 5i squared. So we're going to have to do something with that I squared eventually. On the bottom, 4 times 4 is 16. 4 times negative 5i is negative 20i. 5i times 4 plus 20i. 5i times negative 5i is negative 25i squared. Okay, then we need to simplify. Use as many steps as you want to. Okay. Here, let's combine the middle terms first. How about that? Okay, so we'll do the the I terms first. So on top, that leaves us 24 minus 34i plus 5i squared. On the bottom, if we combine the middle terms, they cancel out. That should happen every time if we've done things correctly. Okay, so then we have 16 minus 25i squared. Okay, now really important to remember that I squared is -1. Right? So we've got two of those to deal with. So plus 5 is going to turn into minus 5. So we have 24 minus 5. That will give us 19. On the bottom, -25 will turn into plus 25. So we'll do 16 plus 25. I've got my calculator because I don't want to do it in my head. We get 41 on the bottom. And then we just look to make sure that nothing will simplify. It's probably easier to see if you split it up into two fractions. So 19 over 41 minus 34 over 41i. That's a plus bi form. 19 over 41, that won't simplify. They're both prime numbers. 34 over 41, that won't simplify because 41 is prime. So there we go. Kind of messy, but there's our answer. Okay. Oh boy. 14. I to the 1,602 power. And remember on these, the strategy I showed you in the video is looking for powers of 2. So we could rewrite this. It's I squared to what power? Well, if 1602 is even, so 1602 divided by 2 gives us 801. So I squared we know is -1 to the 801 power. 801 is an odd number. So -1 to an odd power is -1. -1 to an even power would be +1. So this one, it looks really nasty because we got such a big number, but hey, it's not too bad. Right, we get -1. Okay, kind of cool if you're a math nerd. If that simplifies like that. If not, you might not be impressed. That's okay. All right. 15 says find all real solutions of the equation. Okay. This is, we've got x to the 5th, so this is one of those polynomial equations. So remember, with polynomial equations, are really our only option for solving these is to try to factor. Okay? So what I'm going to look for, since we've got two terms, I'm going to see what we have in common. So I see we have a common factor of 7. 7 will go into 63. And then our smallest power of x is x, so I'm going to factor that out. That leaves us with x to the 4th minus 9. Okay, that equals 0. And then this is the ugly 4. I've got to change it. Let's see. 4. And then the part in parentheses, if you look at it, is actually the difference of 2 squares. So we can factor that again. X squared times x squared will give us x to the 4th. So remember, our pattern there is difference of 2 squares is going to be a plus b, a minus b. And so our a here is x squared. Our b, 3 times 3 is 9, so we've got plus 3 minus 3. Alright, and then that's as factors we'll get. 3 is not a perfect square, so we can't factor that anymore. So now we set each one of these equal to 0. So 7x equals 0. Let's put a little line here. 7x equals 0. X squared plus 3 equals 0. And x squared minus 3 equals 0. And remember on the directions, what did it tell us? It said find all real solutions. Okay, so we just want the real numbers. Okay. So what can we do? We can divide both sides by 7. We get x equals 0. That's a real number, so there's a solution. On the other one, if we do x squared equals -3, well, you might say take the square root of both sides. I'm okay with that. So plus or minus square root of -3. But that's a negative number underneath the square root, so that's going to be a complex number, not a real number, so we don't need that. Okay, what about the last one? Similar strategy. If we do x squared equals +3, then x, if we take the square root of both sides, you have to do plus or minus, so we got plus or minus square root of 3. So we end up with three real solutions. We have x equals 0, x equals square root of 3, x equals negative square root of 3. Okay. The one in the middle, the 3i, we don't care about that one because it's complex, and it said find all real solutions. Okay, number 16 says find all real solutions. We have a rational equation. Remember, with rational equations, we're going to multiply through by the LCD, lowest common denominator. Okay, so what's our LCD here? Well, we only have one denominator, so this one's pretty easy. Our one denominator is z plus 1. So we're going to multiply everything by z plus 1. Okay, so we're going to have z. I do the bar on my z's so I don't get them confused with 2's. I mean, you don't have to do that, but I'm just telling you why. Okay, so z times z plus 1. Alright, and then plus 4 over z plus 1 times z plus 1 equals 3 times z plus 1. So these three places I'm just multiplying by our LCD, right? That's our LCD. Okay. Then we start simplifying. In the first term, we're doing distributive property, so we get z squared plus z. In the second term, we've got z plus 1 on the top and z plus 1 on the bottom. Those cancel, leave us with just plus 4. On the right side, we have distributive property, so we get 3z plus 3. We've got a z squared in here, so this looks like a quadratic equation, so I'm going to get everything on one side. So I only have one z squared term. Then I'm going to subtract 3z from both sides, so z minus 3z, negative 2z. Okay, and then I'm also going to subtract the 3 from both sides, so 4 minus 3 plus 1. Then we get our quadratic equation there. Okay. Again, it says find all real solutions. So if we get complex numbers, we don't have to worry about those. Alright, now what? We've got to solve a quadratic equation. So we can factor, complete the square, or use quadratic formula. My personal preference, if I can, is to factor. I see that we want factors of 1 that give us -2. I think we can do that. I think if we do -1 and -1, that will give us -2. So I'm going to factor. If you don't see that, you can do quadratic formula. That's perfectly acceptable. But I think we can factor. So z times z will be z squared. And then -1, -1 give us, if we -1 times -1 is 1. -1 minus 1 is -2, so that works. These are both the same, so you don't necessarily have to write down both equations. You could just do one. We have z minus 1 equals 0. So that will give us z equals 1. We're not happy yet, though. Okay. Wow, we've got to check this, because remember, we might have solutions that don't work. So let's go back and look. So we have +1. Okay, so if we're checking, that will be 1 plus, okay, 4 on the top. Then we got +1 plus 1, so that would be 2 on the bottom. This equals 3 is what this says. So let's look. So 1 plus 2 equals 3. Yeah, that checks out. So this is a solution. We don't have to be concerned about it anymore. Z equals 1. That works. Okay, that works. All right, number 17. To find all real solutions. So again, we can ignore complex numbers. This time we have a radical equation. So we're going to raise both sides to a power once we get the radical by itself. And this is a square root, so our index is 2. That tells us what power to use. So on this one, the radical is already by itself. I'm going to rewrite the problem this time. So the radical is already by itself on one side. So we are ready to raise both sides to a power. The power we're going to use here to get rid of the square root is 2. Square both sides. On the left, that leaves us 8x minus 1. On the right, 5 squared, 5 times 5, 25. Now I'm going to add 1 to both sides, so 8x equals 26. Divide both sides by 8. And then we need to simplify, so let's see, I know that's 13 over 4. Divide the top and bottom by 2, and that's all we can do there. We can't simplify 13 anymore. So 13 over 4. Oh, I got a little, jumped ahead a little bit there. Okay, so now what do we need to do? We need to check it. Okay, it might not actually be a solution. So square root of 8 times, it's a little messy, but you can use a calculator. Okay. 13 over 4 minus 1. And we want to know, does that equal 5? Okay, so if we do 8 times 13, we'll get 104. Divided by 4, we'll get 26. So this says the square root of 26 minus 1 equals 5. Is that true? Well, this is the square root of 25. Does that equal 5? Yes, it does. So 13 over 4 is a solution. We checked it. Okay, make sure you check, because if you could plug it in and it doesn't work, so make sure you check. Alright, number 18. We got a linear inequality, and sorry, the number line thing doesn't work good on here. We'll just have to draw it out. Okay. So what am I going to do here? I'm going to subtract 5 from both sides, and then I'm going to add 9x to both sides. We'll get our x's on one side. So we do the x part first. Negative 3x plus 9x is 6x. And that's less than or equal to, we got 2 minus 5. So it's negative 3. You can do that in 2 steps if you need to. I'm going to divide both sides by 6. We don't have to flip the inequality because 6 is positive. You only flip the inequality when you multiply or divide by a negative. So we get x is less than or equal to negative 3 over 6, or negative 1/2. It says express the solution using interval notation, and then down here it says graph the solution. I think it's easier to graph it first. So let's see, we'll just call this negative 1/2, make it easy on ourselves. It says our x's, the ones that work, are the ones that are less than or equal to 1/2. So we're going to have, since it's or equal to, we'll have a filled in circle at negative 1/2. And we want the ones less than that, so we are going to shade to the left. Okay. And then for our interval notation, how small can our answer be? Well, it goes forever to the left, so negative infinity. Infinities always have a parenthesis. Then how big can we get? We're going to go all the way up to negative 1/2, and we are including negative 1/2, so we use a square bracket. Okay, so there's our interval notation, and then above that is our number line. Okay, so there we go. There's test 1 review. If you have other questions, let me know. Like I said, I will give you the quadratic formula on the exam, so you don't have to memorize that. You can use a calculator. Okay, so a few people have asked, yes, we're taking a paper test. That way you can show your work, and if you make a little mistake, hey, I can still give you partial credit. It's not like WebAssign where it just counts it completely wrong if you make one little sign error or something like that. Okay, so it is a paper test. So have questions, let me know.